So welcome back to our video on trigonometric functions. We've looked at all of the sine functions in terms of its basic function, change in amplification or dilation amplification, dilation with period, transformation horizontally and transformation vertically. So we can write this all up in one entire formula. So we can write it here as y is equal to a sine b, let's do this a bit better, b minus c plus d, where a dilates the amplitude, okay, and it's always positive. Okay, b dilates the period, and we use the formula of 2 pi on b. C translates, so this here will be horizontal, this here will be vertical, translates horizontally, and D translates vertically. So we can tell from each parts of the sine function a, b, c and d, so let's fix this up, that should be b brackets x minus a, b, c and d, what each part of that formula does. What we're going to look at right now is just quickly look at the cosine. Now cosine does exactly the same thing as sine, except for it looks different in its basic form of a calculation. So we're going to go back to the unit circle, do what we did with the sine function and sketch up what our cosine function is going to be. So recall, when we look back at the sine function, or at the unit circle, we knew that every x coordinate represented cosine and every y coordinate represented sine. So in this case here, at radian 0, the x coordinate is 1. At pi on 2, the x coordinate is 0. At pi, the x coordinate is negative 1. At 3 pi on 2, actually, it should be 0, that should be 0 and negative 1. Yep. At 3 pi on 2, x is 0 again. And then back here again, we get 1. So if we sketch this curve, we get a curve that looks like that. So this here is the cosine basic curve. Y is equal to cosine of x. And this here is exactly the same changes or translation and dilation as sine. So the only thing we would change here is we would change this here to cosine. It has a period of 2 pi, it has an amplitude of 1, and it has a range of 1 to negative 1, just like sine. Now, the only main difference when it comes to cosine and sine is we can think of another identity that works with this. So if I drew up the sine diagram, what can we say about the difference between the two? We can look at this and say, well, let's have a look at the cosine. We can say cosine x is equal to sine x plus pi on 2. Or we can say is equal to, yep, sine x plus pi on 2. Because we're starting at 0 we take sine x and we add pi on 2, and that's where it's actually moving along. So when we're looking at the cosine function in the blue has the same properties as the sine function, except for it uses the x coordinates as its main points. Okay, I'll see you next one.